The James Webb Space Telescope has just confirmed something that has shaken the astronomical community to its core. The interstellar object, 3AI Atlas, already a mysterious traveler from beyond our solar system, has been observed with unprecedented clarity by Webb's instruments, and its trajectory has been pinned down with unsettling certainty. It is not merely passing through the solar system as once thought. The updated data show that it is on a collision course with Mars, a revelation that turns a rare astronomical curiosity into a monumental cosmic event. Before we dive in further, make sure to smash the like button and subscribe so you don't miss future updates on discoveries like this. The telescope's ability to pierce the cold depths of space with its infrared eyes has given scientists the precision they needed to track 3AI Atlas across the dark backdrop of interstellar space. What appeared to be just another passing visitor from the void has instead become a body of immense importance. Its orbit is narrowing, and the gravitational pull of the Sun has guided it into a path that intersects with Mars. Unlike earlier speculations, where margins of error left room for doubt, Webb's observations leave almost no ambiguity. The numbers, trajectories, and models all converge on one conclusion: impact. For planetary scientists, this is both terrifying and exhilarating. Mars, often considered Earth's sibling in terms of planetary exploration, has been the focus of countless robotic missions. Its surface, scarred by ancient craters, already tells a story of collisions across billions of years. But this would not be an ancient scar frozen in time. It would be an unfolding event, an interstellar object colliding with a planet we are actively studying. No human or machine has ever been alive to witness such a thing. The very nature of 3AI Atlas adds to the significance. This is not a fragment from the asteroid belt, not a stray comet looping back after thousands of years, but a visitor from beyond the solar system itself, like Oumuamua before it and the comet Borisov after that. It is an emissary from elsewhere in the galaxy. Its composition may carry materials forged in other stellar nurseries, dusted by the explosions of other stars, and shaped by environments no probe from Earth has ever visited. To collide with Mars means that some of this alien matter will be delivered directly to a planet whose mysteries already captivate scientists searching for signs of past life. The scale of the collision is something Webb's data has made possible to estimate with sobering accuracy. 3AI Atlas is large enough that the energy released upon impact would dwarf even the most cataclysmic natural events Mars has experienced in recorded human observation. The kinetic force would gouge out a fresh crater visible from orbit, lofting debris miles into the thin Martian atmosphere. The dust could hang suspended for months, perhaps years, altering the climate of the planet in ways our rovers and orbiters will be in perfect position to record. Unlike Earth, where atmosphere and tectonics erase scars over geological timescales, Mars preserves them almost indefinitely. The crater left by 3AI Atlas will not just be a fresh wound, but a permanent monument to this interstellar encounter. The scientific opportunities are staggering. Every space agency with instruments in orbit around Mars or rovers on its surface now faces the chance to watch a cosmic collision in real time. Imagine the panoramic cameras on the rovers catching the fiery descent of a body that has traveled for millions, maybe billions of years through interstellar space. Imagine orbiters mapping the explosion and then returning to chart the aftermath, from the spread of ejecta to the way Martian winds move the dust across the landscape. Each image, each data point, would enrich our understanding of impact dynamics, planetary geology, and interstellar chemistry. Beyond science, there is the drama of cosmic perspective. Humanity has always looked at Mars as the next frontier, the world where explorers may one day step. To know that such a planet, so close, so tangible in our imagination, is about to experience a direct strike from beyond the solar system forces us to confront the scale and unpredictability of the universe. The cosmos is not a quiet backdrop for human ambition. It is alive with movement, collisions, and chance encounters that remind us of our fragility and our fortune. For planetary defense experts, the Webb confirmation underscores the importance of vigilance. Although Mars is the target this time, the very fact that interstellar objects can be drawn into collision courses with planets shows how dynamic and unpredictable these visitors can be. The calculations reveal how tiny gravitational nudges from the Sun or from planetary flybys can alter paths dramatically. If 3AI Atlas had been shifted just slightly differently, Earth could just as easily have been in its path. That sobering truth fuels discussions about detection, tracking, and perhaps one day, deflection of cosmic intruders. Mars itself, however, becomes a kind of test case. The impact will serve as a natural laboratory to study what happens when a high-velocity interstellar object slams into a terrestrial planet. Researchers will be able to test computer models against reality, refine their simulations, and better predict what would occur if Earth were ever in the same situation. The debris cloud, the thermal pulse, the seismic waves, all will be measured, compared, and analyzed. Mars is, in effect, becoming a proving ground for understanding cosmic impacts at an unprecedented scale. The timing of the Webb confirmation also heightens the sense of immediacy. Missions already orbiting Mars, such as MAVEN, Mars Odyssey, the European Space Agency's Trace Gas Orbiter, and others, are equipped to gather data from the event. Rovers like Perseverance and Curiosity, still active on the surface, could potentially document the sky as 3AI Atlas makes its final approach. Even if not directly under the impact trajectory, they could record atmospheric changes, seismic vibrations, and the settling of fine dust over their solar panels and cameras. Every instrument, already on or around the planet, becomes part of a coordinated observational network, ready to turn an astronomical event into a scientific goldmine. There is also the haunting thought of what lies inside 3AI Atlas, the chemistry of its ices. Rocks and dust could differ radically from anything in the solar system. The shock of impact will vaporize much of it, but some fraction will be embedded in Martian soil and rock, creating a unique mixing of Martian and interstellar matter. Future missions could one day land in the crater to collect samples, bringing back pieces of another star system that have been fused into the Martian surface. That prospect alone could redefine planetary science and astrobiology. Even more striking is the symbolism of Mars itself as the site of the collision. Humanity has not yet set foot on its surface, yet we are already imagining bases, habitats, and colonies there. The Webb discovery underscores how vulnerable such endeavors would be. Mars is not exempt from the randomness of cosmic impacts. If a future settlement were already in place, this event would have been catastrophic for it. In that sense, 3AI Atlas becomes a reminder not only of scientific opportunity, but also of the risks that await humans as they expand outward. The media attention surrounding this confirmation has been enormous. But at its heart, the story is about our relationship to the cosmos. The James Webb Space Telescope, a triumph of human engineering, has given us the vision to see farther and with more precision than ever before. That vision has revealed not just distant galaxies, but a clear and present event unfolding in our own celestial neighborhood. The story of 3AI Atlas and Mars is a story of how observation transforms wonder into understanding, and how understanding confronts us with both awe and humility. Astronomers are now working feverishly to refine every parameter of the impact, the angle of entry, the velocity at collision, the precise latitude and longitude on Mars. All are being modeled with the freshest Webb data. Each refinement not only gives clearer predictions but also sharpens the expectations for what instruments should look for. Scientists anticipate shock waves radiating through the Martian crust, and orbiters will be poised to detect subtle changes in the planet's exosphere. The full choreography of the collision is being mapped out in advance so that when it happens, nothing is missed. Meanwhile, public fascination is rising. Unlike distant cosmic phenomena that unfold light years away, this will happen on a planet that humans can photograph with backyard telescopes. Amateur astronomers will point their equipment toward Mars, hoping to catch the brilliant flash of the impact. News outlets will follow each step, from final approach to aftermath, and the world will watch together as Mars gains a new scar. It is rare for cosmic events to bridge the gap between the scientific community and the broader public, but this one does. It is both technically profound and viscerally dramatic. The collision of 3AI Atlas with Mars is not just about a trajectory intersecting with a planet. It is about the way the universe refuses to remain static. It is about motion, energy, and transformation. Mars, long studied as a fossil world frozen in time, is about to be struck by something utterly alien. The red planet will change, not subtly, but visibly, and human eyes, guided by robotic instruments and telescopes, will witness it as it happens. That reality alone ensures that the confirmation by James Webb will stand as one of the defining discoveries of this era of astronomy.